All right, pre-calc 11, here we go. More trig. Trig equations and special angles. Good times here on a May overcast day. So here we go. Trig equations and special angles and ratios. These are the pages. There's 2 questions from there and then a worksheet. So, a few things that are of interest today that you need to be aware of. This is old from the last lesson. Just keep that in the back pocket. You don't actually even need that today. You need it for the reason why, which you don't have to really worry about unless you're interested. I'll make a video for you. But the special angles that exist in architecture and in math are all the ones that are zeros. We like zeros, we like 90s. 30s and 60s and 45s. If you've ever bought a protractor set, you get those 2 different triangle shapes in there. Those are your 30s and 45s and 60s. And then this could keep going. But these are the main ones. Like you could just, 120 is another one because that's another 30 added on. 150, 180. In between that, there'd be 135. So anything that kind of has a 30 or a 45 or a 60 link to it. So what you need to memorize, and this is where I'm going to kind of just leave this. Your first exercise is literally just to memorize this table. Now I have it memorized. I know it like the back of my hand now, and then if you need to know why, what I'm going to ask you to do is up in the top corner, I'll link it. You can look at the video of why this is. Right now I'm not going to worry about why. I'm just going to say this is what it is. If you went to a calculator right now and typed in sine of 0, you would get 0. If you typed in sine of 30, you will get exactly 1/2 or 0.5. If you type in 45, sine of 45, you'll get 1 over root 2, or if it's rationalized, root 2 over 2. For 60, you'll get root 3 over 2, or 0.866. Sine of 90 is 1. Cosine, ironically, if you go the list backwards, it's exactly the list backwards. Cos of 0 is 1. Cos of 30 is root 3 over 2. This is 1 over root 2 or root 2 over 2. This is 1/2 and that's 0. And tangent is tan of 0 is 0. Tan of 30 is 1 over root 3 or root 3 over 3. Tan of 45 is 1. Tan of 60 is root 3 or 0.171 blah blah blah. And tan of 90 is a weird one. That's undefined, or it makes your calculator go air, or technically it's infinity. Now if it interests you again, why? Click up on the top corner there, I'll have it somewhere, and you can watch that special video of where and why that comes from. This is not just random McPhee made that up for the heck of it because he's on too much hospital medication. That's not what it's about. Okay, so memorize that. You need to, if you're taking pre-calc 12, if you have any inkling of taking pre-calc 12, knowing this next year will just make your life so much easier. Like you'll be laughing. Like your friends will be like not knowing it and they'll be taking pre-calc 12 and they'll be crying and then you'll be over there kind of laughing. Not at them, but just kind of in your heart going, I feel good about myself. Okay, so we're going to use this knowledge along with all the other angles in standard position with cast rule to develop and solve trig equations. So here is a trig equation, first of all. Much like any other equation we've solved, it's an equation with an equal sign where there's an unknown, and the unknown is going to be some kind of angle, and it's going to be inside a sine or a cos or a tan, hence trig equation. And then they'll give you some kind of stipulation on theta. They're just saying theta is between 0 and 360. If they don't cap you at that, the trouble with trig is you could have answers, remember, like going around and around and around and around. And if they don't cap you at that, there could be like infinite answers. So they're going to kind of keep you contained between the 4 quadrants without going over and over and over. In pre-calc 12, you go beyond that big time. So how do you solve this? First step is you need to isolate the sine, cos, or tan. In other words, get it by itself. In this question, that is already by itself. So that first step, done. Just lucky. Okay? Next step is, because we're dealing with angles that could be now any quadrant, you need to use the cast rule to determine where this could possibly occur. And it comes down, this is really important, the cast rule with the sign being negative tells us something very important about where this is. So with your rule, all suckers take cocaine, where is sine negative? So it's going to be negative in not the all quadrant and not the S quadrant, because that's where sine is positive. It's going to be here or here, meaning there's two potential answers. So what I personally do, I find this overwhelming. So what I do, I usually draw two separate pictures of this. One answer is in quadrant 3, which is this answer, and another answer is here in quadrant 4. Okay? And what I do to show there's two different answers, I usually call this first one theta 1 and this guy theta 2. Just so I don't lose track of what's going on. Okay? So that's the first step. Use the cast rule to find out where you are. Third step is you want to use the positive ratio, so you're going to ignore the sign of it, to find out the reference angle. So the first step is this. Well, second step, I guess. First step was that. Now we're going to find the reference angle. And I always go back to my picture too. Like, for example, where is the reference angle in this picture? My reference angle, which I'll highlight kind of in orange here, my reference angle is right there. Where is it in this picture? It's right there. That's important. You need, because once you know the reference angle, it's so simple to get the actual angle. So there's my reference angle. There's my reference angle. How do I find it? Now, if this ratio is on this table that you've memorized, which looking under sine, because that's what we're dealing with, sine, notice there's a 1/2 here. 1/2 links to exactly 30 degrees. Okay? So I could even look at this right now and go, it's sine theta equals positive 1/2, because remember I'm ignoring the negative because it did its work already. Using the chart, I know this is 30 degrees. Now if you didn't have the chart, what you would then do is what you would have done for any other question before. You would have done second sine of 1/2, and out would have come 30. And you may argue, well, what's the difference? There is none, just that math people love these special angles so much that they'll use this to their advantage for time and energy without having to grab a calculator. Now, if it wasn't on the chart, if that was 1/4, 1/4, the chart would be useless, and I'd have to use the table, or the calculator, sorry. Now, once I know the reference angle, step 4, I kind of like it. It's like a game. I look back at my picture and say to myself, how big is theta 1? How big is this, knowing that this little wedgie in here is 30? Well, that's 180 plus 30. 210 degrees. There's my first answer. The second answer, how do I figure out the size of this angle, knowing this little wedge in here is 30? Well, the trouble is I could work out this angle here, which is 60. I don't prefer to do that. I always use the reference angle. I'm going to go too far. I'm going to go 360. Too far. Back up the truck 30 degrees. And you get 330. Sorry, yep, 330 degrees. So there's your two answers. So theta equals 210 or 330. And then if I was really concerned, I might check with my calculator. Let's check it. Is sine of 210 degrees? It better give me negative 0.5 or I can go home. Well, I'm already home, so it doesn't matter. Or let's see, sine of 330. Yep, negative 0.5. There's the answers. All right, so that's the first little trig equation. I'm going to fold this over and we'll go through those steps. Here's the next example. So what is it? It's an equation and it's got trig in it. Trig equations. First step, I need to isolate that cosine. Well, I would subtract the negative root 3 over and then divide by 2. Just like you're isolating an x, but you're isolating kind of a chunk. There it is. Now it's isolated. Next thing would be, cast rule. It's got a sign on it. It's negative. It's negative cos. So I'd think about my cast rule for a minute. All suckers take cocaine. Is it this quadrant? Nope, that's all positive. Is it the S quadrant? Yeah, because sine's positive, cos is negative, so it must be quadrant 2. Tan quadrant? Yeah, Tan's positive, the rest are negative. And the cosine quadrant is definitely not negative, so it's quadrant 2 and 3. Like I said, for me, I like to draw each picture separately so I don't get all my lines mixed up. There's my first answer. There's my second answer. And then I always highlight my reference angle, knowing, hey, that's really important to me. So first step, isolate. Second step, cast rule. Third step, reference angle. Looking at this, using the positive, is root 3 over 2 on my chart for cosine. Lo and behold, it is. It's a 30. Okay? So I know the reference angle is 30 degrees. And then step 4 is candy. I just use the picture. Looking at quadrant 2 answer. So there's my first answer. How do I find the size of this? Well, it must be 180. Sorry, minus 30. 150 degrees. Theta 2 must be 180 plus 30. 210. There's my two answers. 210 or 150. All right. Hopefully that makes sense. Just a few little things. I'm just going to do, let's do one more example real quick. Yeah, we might as well. Okay, so here's example number 3. It's a trig equation, has 2 tans. Remember, I have to isolate one of them. So just like collecting what I'm going to do, I'm going to do 2 things here. I'm going to subtract the 3 tan theta from both sides. So this would give me 1 equals, so 5 tan thetas minus 3 tan thetas is 2 tan thetas. All right. And actually, you know what? I'm going to change this question just to make it so it does something different. Make this a -7. You don't really know why. It's just to give you a different example. So now to isolate this, I would then add 7 to both sides, and I get 8 equals 2 tan theta. Then I would divide by 2, and I get 4. Doesn't always work out to be nice. And at that point, I've isolated the tan. Took a while to get there. That'll be the hardest part for some people. Now I use the cast rule. So what is this number? This is the reason I changed this here. This is positive. So now I'm thinking, where is tan positive? Cast rule says all suckers take cocaine. Must be in the all quadrant, must be in the tan quadrant. So my 2 answers are quadrant 1 and quadrant 3. So isolation, cast rule, now comes my reference angle. And I'm looking back at the isolated form. Tan theta equals 4 is 4 on any of the numbers for the special angles. No, there's no 4 for tan. So that means I have to use my calculator, which you might even prefer to the chart as you're learning this. I'm just going to go second tan of 4, and I get 75.9 degrees. You know what? Let's round that to 76 just for convenience. So now I have the reference angle. Then comes the picture. Look at theta 1. Knowing the reference angle is between the x-axis and terminal arm, if theta 1 is where that is, theta 1 is the same as the reference angle. Theta 2, if that reference angle right there is 76, how do I find it? Oh, 180 plus 76, 255 or 256 degrees. So there's my 2 answers, 76 or 256 degrees. Done. All right, over and out. We're going to leave it at that. That is solving trig equations and the special angles and ratios.